Федор не нуждается в очередном представлении, я думаю.
So we should not introduce Fyodor once again, and he will tell us about underestimated extensions which we need to take into account. I think we can start. It's 5 p.m. One of the qualities of Postgres when Michael Stonebaker started to develop it was its scalability. And it's quite very well scalable, better than others, which invoked a big amount of different modules. People get confused around these modules. I can't cover all of them now because it's not so much time. I selected only three of them: PG variables, L3, and VOPs. And I will explain in detail a little bit later. PG variables. The initiator was Ivan Frolkov, who is present here today. Once he spent a lot of time working with Oracle, and he really missed session-based variables. To check syntax in Postgres, it's not so easy, and also in other databases. But you can add up a few more functions which will simulate necessary behavior using different syntax. Why was it needed? Initially, this module, the first version, was focused only on session-based variables. Then we extended it for collections to store intermediary results, and then for procedures, transfer procedures, and temporary tables can be used for that. But temporary tables in Postgres is like first-class citizens, classical tables where system catalog records are made, PG, PPN, and others. You can see it, you can place triggers if you really need it. They can be involved as a type to transfer functions. There are a lot of options. They are stored in files using the same scheme in a separate table space. This is the final thing introduced after the final space. And the normal pattern of working with temporary tables: overload cache. Shared buffers do not overload cache, because if some of you tried to set up temp buffers, it's set up to store temporary tables. It is in the cache, in the memory of every backend. Shared buffers are not affected by temporary tables. By the way, that's why they do not have no auto vacuum, and no analyze is relevant for them. Whether it's good or bad, we don't know. We can argue very long that we should redo it and how to change it. It's a question. But now it is as is. Proceeding from properties to create a big amount of tables and to remove these tables is not quite good, because you overload PG class, PG attribute classes, and we saw clients when PG attributes contain 12 gigs. Analyze and vacuum should come. Specific installations were done. There's a billing software providing the opportunity of auto vacuum, and 60% of time is spent on the system catalog, and they do not provide valuable activities with user tables. We all know, and those who operate it, they also aware that Postgres Planner is critically dependent on statistics. because after auto-analyze doesn't come, we should check the point of time where the analyze should be evoked if tables are really big. To solve this problem, we have online analyze module. It can be looked for, and it is designed for the fact that it starts in some sense the auto-analyze function, but inside the process which works with the temporary table. After the trigger happens, change the amount of change tables or lines, analyze or work are launched, and you can fine-tune for temporary tables only, for instance, or some other workarounds. Taking it into account, PG variables works with variables and with collections. This extension was designed within Postgres Professional, and the inputs, the origins are available. You can download it, compile it automatically in your extension. There is no lack of temporary tables, and I forgot one more thing, one more disadvantage of temporary tables, which is conditioned one. When you create a temporary table, when you write your first record in the table, you immediately create a file, 8 kilobytes, the first page on your disk. In the majority of cases, it's not needed, and Postgres Pro Enterprise knows how to write it on the disk only when temp buffers are over. In the majority of cases, when you have smaller tables, smaller temporary tables, it can help. But coming back to PG variables, you should store it somewhere. So PG variables stores the data in the local cache of backend. It's not good or not bad, it's just a peculiarity of this system. It's good to store it in the local memory because you have fast access. On the other hand, it's bad to store it there because your local memory in every backend will need to be regulated and controlled, just not to go out of the memory. The interface is quite functional. It's quite easy. I wrote out all functions which are available in the module. First two functions, I think, well, they should be numbered. The first two are to install and to get the variable. Package means text line of package in those terms which are used in Oracle. Var is the variable name. Then we have 5 letters or 10 letters comment any no array, every type except any array. And the variable can be transactional and non-transactional. What does it mean, transactional? You installed one and then told it roll back, and it will come to the previous state. Moreover, it behaves during creation. When you first create transactional variable in transaction, if you roll it back, so it would disappear absolutely. And to get it, here you have very unexpected strip. I'm not going to tell more about it. Any no array. Does anyone know Postgres so good to tell why this thing is needed? It's a very mysterious thing, isn't it? It's a consequence of a polymorphism. When a Postgres creates a query, he should know what type of variables and constants are there inside this query. The polymorphic function can provide any type. So the planner of Postgres in this case should get rid of this job. It should return null casted for a certain type. And in Postgres it is an agreement that such any no array functions would be returned by the same type, and it will be able to plan. This is a kind of a magic. Next 4 functions are functions related to collections. Record, does anyone use records or roles in Postgres? 2, 3, more. Very good, 7 people, even 8. well, it means that you still use it. You are able now to construct different parts and transform it as an integrate part. You can place the tuple. You should play around with this module, and you think that the first field in this tuple, in this record, is its ID, and so it works with update and select, delete, select. You can tell what specific record you want to have in the first column. Yes, it's not universal.
But you can live with that. Next function is removed. It's clear. It's the checkup for the existence, all the rest of the functions. If not all of them, but if you call it the updated or non-existing package or the name, you will get the arrow in the end. And the exist and remove will allow you to check or to delete the whole package or the whole collection of one derivative. PG is basically to queue up everything and or to look up. For those who do not know the organization of the memory in Postgres, I will not rely on that, but there is a module which has a free access. It works with all the progresses starting from 10 or version 10. You can see how the Postgres wasted memory. So if you often create permanent tables, the progress caching the knowledge about these tables, and since it's not clear when you can delete this caching, so it does not delete it, it never deletes it. So it's in cache context to keep this all information, and you can overload this cache context, and the start will help you to follow up the situations from the current situation, from the neighboring sessions, or from all the sessions. Especially for the developers, it's quite a useful module. And Ivan Fralkov wrote the test, which is a simple version of the join manually. It's a little bit ugly, but still we put in the collection and use during the selection, hoping that it will get better. I'm not specifying the equivalence, but you can do the same in the select or in a permanent table, temporary table, sorry, and the temp tables, those temporary tables, it's an easy query, and when the query is complex, then putting all this table together will help you, because there is a global problem for all the planners. As more joins you have, as harder it is for you to choose the correct order of the joins. Speaking about the optimization and correct indices. And also it's hard to do when it's hard for you to forecast what will be a result and what type of the results. It depends on the distribution. So if the select is in one table and Postgres makes a mistake, it's rarely the error is 1%. But if you join it, then I know the cases when we do it, we initiated and constructed specifically, we made the patch join selectivity for indices. Nevertheless, when the lane in this particular example will work faster than usual tables, PG variables, we change the tables for storage in memory. But keep in mind that when you do a big selection, you will not be able to fit into the memory. So you'll not be able to use it for every case. So all the rest of the inputs, for instance, what's the average width? 1 kilobits, like it will be 30 gigs, and it's hard to say if it will be running or will not running. One server, you, for instance, on 1 terabyte, and this will be your 30 gigs will be your cache processor. So you need to calculate. For the run, today we've already said this a couple of times, but let me finish it. So my global task is to keep the trees in the database, in Postgres. So we have the general approach, which is double columns, client ID and parent ID, sorry, child ID. So keeping the graph, not only the tree. What's the difference between graph and the tree? Can you show it? Not show it in your hands, with your hands, but please come up with a short explanation. Each node has no more than one parent, only one parent except for the oracle. But that's short description. Every node has some upside down I or exist. Quantrum, yes. Plus to that, if the query is for the fixed level in your application, you can deploy it and make some joins. But the correct way of working with recursive is, maybe not everyone knows, but Postgres is able to operate with cursive queries, but sometimes when you cycle it, then all of a sudden you hit Postgres going into whenever. So basically you can do the temporary table, PG variables, but for the tree it can be overloaded, and for some deep trees it could be very slow. There is also things like nested sets. When a parent has double coordinates, like axis x, and his children should have some coordinates inside. So the approach is correct, but in order to pick up all children, you need to choose all the messages within that frame, within that range. So what is left is what is given, and what is right is the limitation on the right. So everything's good until you update it. When during the update you need to rewrite all the right limitations, and it's hard to guess how your tree is growing. Nevertheless, you can do that. There is also a different approach, which is called path encoded. It's also called materialized path or label tree, or even a level tree, L tree. For the file systems, did any of you see Linux slash USR, local, all that? Did you see that? This is it. Simply that, but instead of slash, backwards or forward, you use the dot. The dot, Oleg and I, we decided the dot is just beautiful visualization. There are other different approaches, but and this is one of the examples. This is top root, and the root, one of the roots is empty. Top science astronomy, top science astronomy astrophysics, top science astronomy cosmology, astronomy, stars, galaxies, and so on. So this is our tree, but it's not wood trees because astronomy is doubled here. So based on the file system, AO3, these are different directories, different paths, different flags. And luckily, there are no symlinks, tree links, so it does not support. And I hope it will never support. Simple queries, for instance, to find all parents, find all the followers. Okay, these are parents. This corner shows the wider agglomerate. All children find third queries to find all the flags with the word astronomy, and the fourth query to find all flags, all L3s with that start with the word astro. This is why with column L3 you can build up the index. This index will operate fast, about 10,000 faster, but this is not B3, this is not unique B3 tool, so it will not be that fast as unique B3. So roughly speaking, the collection of 1,100, which the compatibility will be 10 milliseconds, depends on the equipment, but not half milliseconds as B3 does it, but also the value, the results that you are looking for. You can say top star and look up for all of them that have the stars. You'll get the table, but it will not be able to do it fast enough. Next extension is VOPS, Vector Operation on the Processor. With PGConf, we've had some experience, and one of our developers with Initiative Direct said that unfortunately in modern processors we do not use vertical operation. So keeping and storaging, I don't like the translation, it says storaging data in tiles. Some say you use it as the tiles or the floor tiles, and to that tile with a modern processor can calculate them just with one command, or we can compact them, and the disadvantage is this is hard to update them, and it is even harder to delete it. And it's bad to delete it completely, because if you delete it and it not correctly, it will be done not correctly, then you have to remake the tiles. So in other words, you need to have your own vacuum. For you to have it maximize practical things for the final user, this is the imitation of the table, so it looks and smells like a table through Postgres FDV, Fair David Trapper. Did anyone work with it? So there are more people working with FDW than with L3. So it's a very useful feature. VOPS saves up the time. First of all, when we need to make the calculation, we need to take the info from the disk. We have the tuple, which is quite long, and we need to take the figure from it. So if you've never been inside of the Postgres, you probably have no idea, so I'll try to explain how it looks like. Time limitation. So we have some columns in a row, and some of the columns are missing because they are null in that description. And the second thing, which is negative thing, that you get the column with derivative, some sort of email variable. In each description, it has its own length. So for you to get the second column, you need to see repackaging and see the previous line. And it's not cheap, and you lose some time on it. And also, for this problem in Postgres 11 version, we have just-in-time compilator that allows to fight us. But again, it's not. It can help you once or twice, but not all the time. Interpretation, when they get the query in Postgres after ST3, after optimizer, we get something like bytecode. Doesn't look like bytecode, but nevertheless, it's something that distributed takes it as a bytecode and is trying to implement it. So all the interpretations are expensive. Next one, extra abstraction. So this is extension of Postgres. This does not help because we took two figures together, and this is the function which helps us to put two figures together while using the program and keeping going. So this is extra abstraction for some single tasks. Does play a bad role on us. So if someone you try to use the pull executor, there are two base executors, pull and push executors. Pull executor is easy for understanding. It's a tree or a linear calculator where each node tells you, please give me next result. So it's easy to understand how it operates, but unfortunately it's unpredictable based on the process. We always change the context, jumping from one node to another and backwards. And push executor does not have such problem, but it's a bit heavy or hard to say for understanding. It's even hard for me to explain. The only thing I can say that it pushes everything, and suddenly we have some problems with MVCC. Until we read it, we will not be able to see it, and if it's a previous transaction, then the status is not written yet. Then we need to see the status of this transaction, if it's finished or not, and if it's old transaction which didn't get the vacuum, when auto vacuum was turned off, for the status of transaction we need to go, this is commit log, and bring this page up and see if it's if this transaction is committed or not. Because this all brings to overhead. VOPS has the disadvantages, but it does support not so many operations for arithmetics and coordination of two operators, comparison of and logic operators. This is what you have, two requiries, and if you look more in detail, the only thing is an off-run. All the rest we programmed in linear digits. And this is the difference on the test with CTP. For the queries Q1 and Q6, it's 20 times faster, 50 times faster. This is the time economy. This is limited, and this thing can be used where you have the analytical query. Insert and delete only. There's no update at all, only the limitations, only filters, and the joins are not supported, only filtering and aggregation. This module for the narrow usage only. The people who are working on it, these are the names, L3, variables, Konstantin VOPS, Artur Zakirov, variables, and Sergei Cherkashin, Oleg and I, we were working on L3, and Ivan Frankov, PG variables. Small cool was not on our mind because I'm just a developer, I do not use it. Questions? Two questions, time only for two questions. Well, thank you for your presentation. As far as I understand, L3 has the same problem as test interval tests set. It's not possible for update. It's quite expensive operation. No, on the contrary, when you change the position of the node in the tree, you change this node with L3. You do not need to relocate it. If you want to keep the order on the tree, yes, you need to think how you can do it. Yes, naturally using the flag for the setup of the order. Maybe it's not quite useful, but if we updated the parent, if we changed the parent, okay, if you want to change the branch somewhere else, the whole branch, the parent, then yes, you need to update each message in that tree, in that branch of the tree. Thank you for your presentation. You said something about the concrete module, which describes the state of memory, NemStars, yes. How do you interpret the bytes, or what's the second meaning? In order to interpret its values, you need to know that Postgres operates with memory, context memory, with long life, short life, and existing, and it has their own. It's not its own name. Empty Postgres that was deployed has backend has 6 different contexts. There are many of those, so you can simplify them. Each backend tells about the current status, and you can look there and see what's happening. This is the way how you can get the arrows of wasting the memory. So Fyodor is, I will be here, and I will be able to answer your questions. If you have any, please come up to me.